All right, here we go. So remember, this is given because it was given to you. So for problem number 31, this is a parallel problem. Right on. See? I'll give it to you just a minute. If you want, you can take notes. Use a notebook in that cupboard right there. And next one. There you go. Got it. And you can use these pens. All right, here we go. Tristan, you ready? What do I do? How am I looking at this? So remember, it's y equals mx plus b, right? And I don't see a b, so what is the b? 0, right? If there's not one there, then we can make it look like this, right? By adding 0. Does that make sense? So really, it's just going through the origin. There's still, at 7/4, you have a slope. You got to remember that this is your slope, this is your y-intercept. Okay?
Fucker.
Sorry, hey, watch the language. This is your y-intercept. Okay? So, then, oh, I took my pen somewhere. Great. We want to go with the next step, and that is y equals mx plus b. That is definition of linear equations. And what that allows me to do is kind of set some things up. I know what the slope is, right? I also want to talk about what is parallel. Actually, that would be my next one. Not using this one yet. Your first set on this would be to say, okay, if m, well actually you do need that one first, sorry. You do need the y equals mx plus b, and that is the definition of linear equations. Because that lets you know that this is set up as m and b. From there you need parallel. What does parallel mean, right? So, what is, if m is equal to 7/4, right? Then, guys in the back, please. Who's ever got that computer on? Josh? Turn it off, please. Alright. So, if m is equal to 7/4, right? Then what is the parallel? What is m parallel going to be? So you have to remember, what does parallel mean? Are they the same slope? Or is this the one where they're opposite inverses? So what is parallel? What is parallel, guys? Come on. Parallel. Two lines don't intersect, right?
Same.
They have to be the same. Thanks, Tristan. Come on, man. This is not rocket science, people. Okay? They're the same. You have to know this. Okay? So if they're the same, then the parallel line is going to be 7/4. It's that easy. Okay? Now, they want it to go through this point though. So they want it to have a parallel slope, but they want it to go through this point. Which means we got to plug it into that equation. Okay? We need to use these points to plug into this equation, right? So we're going to use this slope, the parallel slope, and we're going to talk about y parallel now, okay? So when we plug it into this equation, what is y? So this is x, this is y, so -3 is equal to what's m? 7/4, and what's x? -4 plus b, right? Now we can't put in the 0 here because that would be the same slope. We don't know what the b is when it goes through this point. Okay? It might be 0. And it probably isn't. Okay? So, then we solve for it. And the nice part about this one is that, oh sorry, this was substitution, right? And, this was definition of parallel slopes. Okay? So, after substitution, we're able to look at this equation and say, okay, the negative 4 cancels out, so the 4's cancel out, so it's 1 and 1. So it's still negative 1 times 7, which is negative 7 plus b equals negative 3. And that was easy, just PEMDAS, so MD, the arrow on top, because it's PEMDAS. We're just simplifying the equation. Next, we want to get b alone. So now I can add the opposite. So I can add 7 to this side. And if I do that to this side, I do it to the other side, right? So these cancel, and I get b alone, and this becomes 4. So by b is 4, and all I did was subtraction addition from the opposite side, so SADMAP, SA, right? Okay, now, how am I going to write the equation? And I go right back to my definition of y equals mx plus b, right? And I write out my y equals x, and then I plug in my m, and up here I have m is equal to, or m parallel is equal to 7 over 4, right? And this is actually what we were doing here, was we were solving for b parallel, the parallel b, because the first b was 0. This new b is being moved, and it's at 4. Okay? And that would be your equation. So, at this point, we're just saying, hey, this is substitution, right? Right into our equation. Now, you don't have to do the graph, but I want to do the graph real quick, just to show you what's going on with these two equations. Okay? And they're really easy to graph, guys. And you got to be able to do this. By the end of this week, if you're not doing this, you're way behind. Because we've been working on this for 2 months. And we're going to move on when we come back after next week. So, again, I'm sending these things home with you when you come back after next week on Monday. Determined on what you do on this test. Okay? You need to be able to graph both of these. You need to be able to tell me that this graph starts right here at the origin. It goes up 7, so 1, 2, 3, 4, 5, 6, 7, and right 1, 2, 3, 4. So 1, 2, 3, 4. And that's the slope, okay, of that first line. The last line still goes up and over 7, up 7 and over 4, but it starts at a different point. It starts at 1, 2, 3, 4. It starts right here. Then it goes up 1, 2, 3, 4, 5, 6, 7, and then it goes over 1, 2, 3, and 4, right? And so now you have this line, and they are parallel because they're the same slope, so they will never touch. Does that make sense? All they're doing, and later on next year, that's what you're going to be learning, is how do we shift these up? And you'll notice it gets shifted up when we add 4 or we change that b value. Okay? So if I add to the whole equation is going to go up. If I subtract from the whole equation is going to go down. Does that make sense? That's what you'll be learning in Algebra 2. Right now, you need to understand how to graph this equation and this equation and know the difference. Okay? All right, there you go. That's parallel.